All right, so for our last topic this week, we're going to stay in section 2.1, and we're going to look at what's called angular velocity. All right, so basically, the idea of angular velocity, okay, it measures the speed of something, but it doesn't measure the speed of something traveling straight. Okay, for example, in your car, your speedometer measures miles per hour or kilometers per hour. That's the speed in a straight direction. Sometimes we measure the speed of things that spin. Okay, if you have a tachometer in your car, you might see numbers from like 0 to 9, and there's a certain units that it uses. Okay. Anybody know what the units are for a speed of an engine? Yeah? RPMs. Okay. RPMs is an example of angular velocity. It's measuring how many revolutions something's doing per minute. Okay, so we'll talk about why do they use that. Okay, certain power tools use that too. Like if you're familiar with like sanders that have a disc that spin, or certain drills, they may have a certain RPM they operate at. And we'll just say, well, why don't they just give the speed in miles per hour of the drill? We'll say why they use RPMs.
What about, say, like a bullet comes out of a gun, how it comes out and spins? Can you measure that?
So yeah, there's a couple things you could measure with a projectile. You could measure either the speed it's coming at you or how fast it's spinning. Yep. Yep. All right, but in order to be able to do that, we have to know how to convert between units. Okay, so what we're going to do is just practice a couple basic conversions first, and then we'll get into some angular velocity problems. All right, so what I want to do here is just try to convert days to seconds. Okay, and I want to do it in a very systematic way. Okay, every time we convert between units, we're going to use a conversion factor, right? Whether it's in 1 minute, there's 60 seconds. In 1 day, 24 hours. Okay, things like that. So some of these conversions you do have to know. And we always go one step at a time. Okay, so if we want to get days to seconds, what's the next unit that's smaller than a day? An hour. Okay, so we're going to get hours next. Okay, if I want to get rid of days and get it down to hours, where would days go? Top or bottom? Bottom. Okay, so we're going to put days in day in the bottom. And what's the conversion between days and hours?
24 hours, 1 day.
So 24 hours in 1 day. Okay, now because we have days in the top, days in the bottom, we just canceled out days, and if we did this out, we'd have a calculation now for how many hours in 4 days. Okay. Now, what's the next unit smaller than an hour? Minutes. Okay. I'm trying to cancel hours. So where would hours go in this fraction? It's going to go in the bottom again. You guys said minutes was the next unit. That's going to go on the top. And what's the connection between hours and minutes? 60 minutes, 1 hour. Okay, so your choice here would have been either 60 over 1 or 1 over 60. But you have to make it so your units cancel. That's why we put hours in the bottom. Okay, now our unit that's left is minutes. And we're going to go to our last conversion to change minutes to seconds. Okay, what's the connection between minutes and seconds? 60 seconds, 1 minute. And where do we want to put the 1 minute? Top or bottom? Bottom. 1 minute, 60 seconds. Okay, now we look back through all the units and look at what we're left with. Seconds. Okay, now these are just fractions. Okay, so we just multiply straight across. Okay, my denominator is just 1, 1, 1. That doesn't always happen, but in this case, there's no denominator. So we have 4 times 24 times 60 times 60. So there's 345,600 seconds in 4 days. question on that conversion? All right, so we can pretty much do the same thing with a rate. Okay, this 4 days, that's not a rate. That's just a number of days. But now we're going to look at doing something with a rate. Okay, I want to change 14 feet per second to miles per hour. Okay, and we're going to use exactly the same approach we did in example 1. Basically, the idea is we have to change feet to miles, and then we're going to change seconds to hours. Okay, we're going to do each one of those things separate. Okay, first thing I like to do is just write this as a fraction. We travel 14 feet every 1 second. It's 14 feet per second. Okay, and it doesn't matter what unit we start with. We can either get feet to miles, we can do that first, or we can change seconds to hours. Let's get feet to miles. Okay, what's the connection between feet and miles? 5,280 feet in 1 mile. Okay, do you want feet in the top or in the bottom? Bottom, because we want to cancel it out. Okay, so if you don't know that conversion, that might be one you want on your reference sheet. 5,280 feet in 1 mile. Okay, what are my units that I have now? Miles per second. Okay, so I've got the miles, but now I got to change seconds to hours, and we're going to use the conversions we did in example 1. Okay, we know there's 60 seconds in a minute. Do you want seconds in the top or the bottom? Top, we want to cancel it out. 60 seconds. 1 minute. Okay, now if we stop here, we have a speed in miles per minute. We've got to go one more step. Okay, anybody think they can tell me my last fraction, what it's going to be? 60 minutes, 1 hour. Perfect. Oops. Minutes cancels out. Okay, look at your units you're left with. Miles in the top, hours in the bottom. Now just multiply all that out straight across. All right, so we've got 14 times 1 is just 14, times 60. Okay, times 60 again. And now divided by 1, 5,280, 1, and 1. So just divide by 5,280. Okay, so if we had an object going 14 feet per second, that's about 9.55 miles per hour. And you could put MPH, or you could just write miles per hour. Okay, so any question on that one? Okay, so that one's a rate because it has 2 different units in it. It has a distance unit and it has a time unit.
Why did you bump it up to 5
Did that round up? Yeah. Because that third digit is a 5 or higher. Okay, any other questions on that? Okay. All right, so that last example we did, that's an example of linear speed. Okay, it measures the speed of an object traveling in a straight line. Okay, and some common units you might see in the U.S. You see miles per hour. If you go to other countries, okay, I know like Iceland, Norway, I know those two. Probably most other European countries, they use kilometers per hour when you're driving. Okay, feet per second. Okay, anytime you have a distance divided by a time, right? That's a linear speed. And that's your formula for how you normally calculate speed. Okay, some people write distance equals rate times time. This is the same formula. Except instead of having distance by itself, I have speed or velocity by itself. So for example, if you drove, say, 200 miles, and it took you 4 hours to do that, that means you were traveling an average of 50 miles per hour. 200 miles divided by 4 hours, and your speed is 50 miles per hour. Okay, any question on that formula? All right. Okay, so next thing we're going to look at is what's called angular speed. So examples of angular speed, you can still use the same time unit. You can use minutes, you can use hours, you can use seconds. But the way we're measuring distance now, it's not going to be measured in feet, miles, kilometers. Those are for measuring straight distances. Okay, we're going to look at how to measure the distance of something spinning. Okay, and usually we can measure that in revolutions. Okay, like how many revolutions something makes per minute. As I said earlier, you see that in your car sometime on your tachometer. That's RPMs. We could measure something in radians per second. Okay, radians measures something spinning. And so does degrees. Okay, degrees per minute, degrees per second, degrees per hour. Okay, and any of those would be angular speeds. Okay, if our book asks us to find angular velocity, okay, this is what we'll generally use. We'll use radians per second. Okay, because some of the questions in the book are pretty vague. They just say, find the speed of the object. And they don't tell you what units to use. Okay, so if the book ever does not tell you the units to use, always use radians and seconds. If they ask you to use another unit, then just we'll do what they ask. But kind of as a default, if they don't say anything, we use radians and we use seconds.
All right, so for the equation for speed, V equals, what was over the T?
Distance over time.
It was an S though?
Yeah, that's just the letter that I used for distance.
Oh, it doesn't have to be S though?
No, you could use, some people use R for rate instead of V for velocity, but they mean the same thing.
Okay.
Yeah. Right? And now, have people seen it like this, or do most people use distance equals rate times time?
Oh no, I was just
Either way.
That's how you just put it. I was confused.
Okay. Let's see why we need to use angular speed. Why don't we just use linear speed for everything? Okay, I want to take a look at this picture. Okay, let's make it a little bigger. Okay, on this circle, I've got 3 different dots. I've got kind of a black dot in the center, then a red dot, and a blue dot. Okay, and I'm going to spin this circle, okay, 1 revolution, maybe. I'm just going to spin it 1 time. Try to stop where I started. Okay, which dot traveled the farthest?
The outside.
Yeah, the one on the outside. Okay, the blue one traveled the farthest. Which dot traveled the least? Yeah, the one in the middle. In fact, if it was exactly in the middle, it would look like it's not moving at all. Yeah, I think that does look pretty centered. So it doesn't look like the one in the middle moves at all. The blue one moves the furthest, and the red one moves, in the middle. It's in the middle of the 2. Now, if you compare the time it took the black one, the red one, and the blue one to make 1 revolution, how did those times compare? Right?
Be all the same.
They're all the same. Okay, the red dot, the blue dot, and the black dot, they all did 1 revolution in exactly the same amount of time. Say it took 3 seconds. But what would that mean if the blue one traveled farther in the same amount of time as the red one? What would that mean? Think about if you were driving somewhere and you ended up farther than somebody else and you both drove for an hour. What would that mean?
The blue one's traveling at a faster speed.
Right. If we measure it using linear speed, since the blue one traveled farther in the same amount of time, it must be going faster than the red one. Now that gets confusing, right? That means every dot on this circle that's a different distance from the center would all be traveling different speeds. And that's weird, that's kind of confusing. So instead of talking about linear speed when something's spinning, that's why we use angular speed. Because we can say all these dots made one revolution in, say, 2 seconds. Okay, 1 revolution every 2 seconds. And it gives them kind of all a common speed. Now the blue one is making a bigger revolution, but that we're not worried about that. Just it made a revolution. Okay, it simplifies it. So that's why we use angular speed. Okay, so bless you. Okay, in angular speed, okay, our formula looks very similar to what we just had, but instead of velocity, now we have angular velocity. Okay, your book uses this letter that kind of looks like a W, so just to match up with how your book does it, I use the same letter. Okay, we still have time in the denominator, just like we did before. But notice here, we don't have distance in the top. It's not distance divided by time. It's your angle divided by time, whether you measure it in revolutions, radians, or degrees. Those are the 3 ways you can measure something spinning: revolutions, angles, and degrees. Okay, so any questions on that formula? So as an example, I could say, let's say something was spinning at 200 radians every 2 seconds. That's a speed of 100 radians per second. Okay? If it moved 200 radians in 2 seconds, if I reduce it, it's moving 100 radians per second. And if I really wanted, we could change radians to revolutions or seconds to minutes and find RPMs. Okay, I'd say most things are RPMs for everyday usage. That's what you'd probably see on like power tools in your car, things like that. All right, so let's try an example where we convert 4,000 RPMs to radians per minute. Okay, just in case they write it like this on the test, can somebody remind me again, what does RPM stand for? Revolutions per minute. Okay, if you had a question and you didn't know that, I would tell you that, but that's what RPMs are, revolutions per minute. Okay, so we have 4,000 revolutions every minute. Now, is there any unit here that we're not going to have to mess around with? It's already what we want. Minutes. Okay, we're starting in minutes. They want the final answer in minutes. So we don't have to worry about minutes. We just need to change revolutions to radians. Now, even if you don't know the connection off the top of your head between revolutions and radians, where do you think revolutions would go? Top or bottom? Yeah, it's got to go in the bottom to cancel out. Okay, but now we need to know the connection between how many radians in a revolution. Does anyone remember that? I know it's 360 degrees, but we don't need that here. How many radians in one revolution? 2 pi. Yep. Okay, so that's a conversion you need to know. Okay, there's 2 pi radians in one revolution. Okay, and now just multiply it out. Okay, we have 4,000 times 2, that's 8,000 pi radians per minute. I just did 4,000 times 2. Now, if they want a decimal, we could find that too. Okay, just take 8,000 times pi. It's about 25,132. 0.74 radians per minute. Okay, what's the difference between the top answer I wrote and this bottom answer? They're both correct. But what's the difference?
One's a decimal, and one of them uses the 5 one.
So this answer, is this an exact answer, this top one, or is this an approximation? The top one is exact. Okay, this is an exact answer. Okay, 8,000 pi. Once you type in the pi button and then round it off to 0.74, 0.74 is not really the answer. Okay, we've rounded it. So this bottom one is an approximate. Okay, if they ask for exact answers, okay, you got to write the top one. Approximate, you can write the bottom. Okay, any questions on that? That's
So, top one you just did, you just typed in the calculator 4,000 times 2,
yeah, I just did that part in my head, 4,000 times 2.
and then with the bottom one I did 4,000 times 2 pi, and I got that bottom answer.
Yep,
Just how you do that.
that's how you do that, that's how you get the bottom one. Yep. Just make sure when you press pi, we use the pi button on 3.14.
So for this, we're writing radians, right?
Yes. Yep.
We weren't writing it, so now we
Right, we have to label it because it's part of a unit, okay? If we don't put it, we wouldn't know. Okay, so anytime you have a rate, you got to have radians and minutes, or seconds, or hours, whatever the unit is. Yep, that's a good question. Any other questions? All right. Okay, example 4. I don't endorse trying this problem. Okay, so a child is using a 2-foot rope and they're swinging a rock at 180 revolutions per minute. Okay, I want to find the linear speed of the rock. All right, so this is the first time we've done this. So basically, if you think about what's happening here, okay, child swinging a rope, 2 feet long, it's going around 180 times per minute, and he lets the rock go. Right? If he lets it go, that's how fast it would be moving. Right? The linear speed. You want to visualize that? Swinging it, lets it go, the rock takes off straight. We're going to find out how fast the rock would be going. Okay, so any questions on what we're going to try to figure out? All right, so at some point, we're going to end up using the formula for circumference. Okay, if we want, we can figure this part out right now, but we're going to need it eventually. Okay, so I just put up the formula to remind you. Okay, circumference is 2 pi r. Now, what's another name for a circumference? If you imagine this rock going around one time. Okay, it is the circumference of a circle, but the rock is also making one what?
Revolution.
One revolution. Okay? So 1 revolution equals the circumference. The only thing we have to do is figure out what the circumference is. Okay, but 1 revolution is a circumference. All right, so here's our formula to figure out the circumference. What's the radius of the rope? 2 feet. So my circumference is 2 pi times 8, and 2 times 8 gives me 16 pi
I think
feet.
8.
Oh, sorry, 2. I don't know why I put 8. 4 pi feet. Okay, any questions on that? So now we know how many feet in one revolution of this rope. Okay, there's that many feet in one revolution. Okay, put that conversion off to the side. We're going to use it eventually, but we needed to figure that out. Now, would that be the same for every problem? For example, there's always 60 seconds in a minute. There's always 60 minutes in an hour. There's always 24 hours in a day, no matter what problem you do. But is there always this many feet in a revolution? No, it depends on the size of the rope. Okay, it depends on the radius. Okay, smaller radius, smaller circumference. Bigger radius, bigger circumference. So this is a conversion that's different in every problem. Okay. Different in every problem. The only time that this conversion would be the same is if you did another problem about something with a 2-foot radius. There's that many feet in a revolution. All right, so let's start with what they gave us. Okay, what did they say the child was swinging the rope at? How fast? 180 revolutions per minute. Okay, and our goal is to get MPH. Okay, what does that stand for? Miles and then hours. All right, so let's get minutes to hours first. Okay, let's take care of that. Okay, Ashley, what's my conversion from minutes to hours?
60 minutes in an hour.
Yep, 60 minutes in 1 hour. Okay, so I've got my time unit. And now I've got to get rid of revolutions and change it to feet. Okay, so now we're making the jump from something spinning to something traveling straight. Okay, this is the first time we've done that. Where do I want revolutions? Top or bottom? Bottom. Okay, and in one revolution, how many feet are there? 4 pi, that comes from the circumference.
Why didn't you do
Question on that?
I was wondering whether, I would have done I was doing the rep and I thought we were skipping the revolution first.
You can do this one first if you want.
Yeah, it's-
You gotta do them both eventually. So, yep. Okay, is that what they wanted? Feet per hour for our final unit? You want miles per hour? Right. So, Stephen, what's my last conversion here to get rid of feet?
5,280 feet is 1 mile.
Yep, 5,280 feet in 1 mile. Right, so let's see what happens. So if the kid's swinging the rock on a rope 2 feet long at 180 revolutions per minute, and then they let it go, we're about to figure out how fast it would be going. All right, so we got 180 times 60 times 4, okay, times pi. Okay, you can do each one individually, that's fine. And then divide by 1, 1, 1, so you don't have to worry about that. And lastly, 5,280. Okay, so it's going about 25.7 miles per hour. Any question on that? Yep, Stephen.
I got 8.8 feet.
And you typed all those in?
Yeah, there's 180 times 60 times 4.
Okay, let me just check it. 180, 60, 4, and you did pi as well?
Oh, I didn't do pi, that was the problem.
and then divide by, should get 25.7 miles per hour. Okay, any other questions on that one? All right. Okay, why don't take a second and see if you can do this one on your own. Okay, they're telling you here that you have a radius of 5 centimeters. Okay, and in 20 seconds, this object moved 1/3 of a radian. Okay, that's kind of a weird way to describe the speed to somebody. That's like saying to you, I drove 300 miles in 3 hours. Okay, well, if I really wanted to tell you my speed, it would be a lot simpler if I just said I drove 100 miles an hour, rather than saying I drove 300 in 3 hours. Okay, that's kind of what they're doing here. They're telling you in 20 seconds, it went 1/3 of a radian. It'd be a lot simpler if they just said how far it went in 1 second. Okay? So that's the first thing I want you to figure out. Angular speed. Okay? And remember, you have a formula. W equals. Okay? Take your angle in radians, divide by the time. And then, after you get that, I want you to convert that to linear speed. Okay, and I wasn't very specific about units, so let's just convert it to centimeters per second. That's the easiest thing to convert it to, since you already have centimeters and you already have seconds. Okay, but you got to get angular speed first. Okay, and you can do that one in radians per second. Okay, so take a minute, try that, and then we'll go over that, and that'll be our last one for today. All right, so just to start people off with the angular speed, so you get something to work with. Okay, what was our formula? The W equals what? Theta over T. So in this case, it's 1/3 divided by 20. Okay, since I had a fraction in the top, I made 20 a fraction in the bottom. And then how do you divide a fraction by a fraction? Yeah, multiply by the reciprocal. So we're going to flip it. So we have 1/3 times 20, 1 over 20. Let me flip it. And what is 1/3 times 1 over 20? 1 over 60. And what's my units on that? Yep, I had radians in the top. What did I have in the bottom? Seconds. It's radians per second. Okay, so that's your angular speed. 1/60th of a radian per second. Right, so that's your first step for linear speed.
Do you want it in a fraction, or like on the crest or something, or do you want it?
We could do a decimal too. That's fine. Does anyone want me to change that to a decimal?
0.097.
Okay, we'll just leave it then. Right. So your speed is 1/60th of a radian per second. Okay, very, very slow. 1/60th of a radian per second. Now you're going to have to multiply by a few conversions. Okay, I'll give you a hint at what the conversions are going to look like. First thing you have to do is change radians to revolutions. Okay, and then your next conversion is going to change revolutions to centimeters. Okay, this conversion you should know. Okay, we did that earlier. How many radians in a revolution? This is the one that's different in every problem. You have to figure out how many centimeters in one revolution. Okay, to see if you can figure that out from there. All right, so any questions on the first part? How we figured out the angular speed. Okay, we just took 1/3 of a radian. That was our theta. Our time was 20. We just did 1/3 divided by 20. That's 1/60th. Right? So that's our starting point. We're traveling 1/60th of a radian per second. Right? Now, anytime you're going from angular speed to linear, okay, you have to use revolutions. Revolutions is kind of that crossover point where you go from something as an angle to something as a straight distance. So this fact, we have to know it. Okay? How many radians in a revolution? Okay? If you're not sure, think how many degrees in a revolution. Okay, start with that. 360. But now I need 360 in radians. Okay? So how many radians in a revolution? 2 pi. Okay, so 2 pi radians in one revolution. Okay, now you'd have a speed in revolutions per second. Now, my last step, okay, I got to get rid of spinning, got to get rid of revolutions, and change it to a straight distance. Okay? I chose centimeters because that's what they chose in the problem for me. Okay, generally I pick the unit that they give me. Okay. How am I going to figure out how many centimeters in one revolution? It's the circumference. Okay, so your radius is 5 centimeters. And basically, imagine this as a piece of string. You're cutting this string and you're laying it out flat. You're finding out how long is one revolution in centimeters. Okay. What's my formula for circumference? 2 pi r. So in this case, 10 pi. So if this was a 5 centimeter circle string, you cut it, laid the string out flat, it would be that long in centimeters. So there's 10 pi centimeters in how many revolutions? 1. And now we just multiply, and that's our answer. Okay, so we have, let's see, 1/60. Okay, which is that, times 1 times 10 times pi. Okay, you don't have to worry about the times 1. Times it by 10. Okay, times it by pi. Actually, you know what? The pi's we're going to cancel out. So now I need to divide by pi. If I was smart, I would have just canceled them out. Does everyone see that? Right, so now I'm going to divide by 2. And because I didn't cancel pi, now I got to divide by pi. And that's it. So my speed is about 0.083 centimeters per second. So as I said, this is extremely slow. Okay, it's not even moving that far per second.
Wait, I got 0.0083.
Anybody else get 0.083?
Yeah. 0.08.
Okay.
I get 2.
You like maybe forgot the 10? Okay, just
Yeah, I did.
okay. If you got something different, just double check. But I'm pretty sure we did that right. Okay. So any questions on that one? So sometimes if you get stuck, it just helps to set up your fractions. Put your units where you want them to go to cancel out, even if you don't know the conversion yet. Just write out the fractions, and then try to figure out what the conversions are. Okay? But the only conversion that you're going to have to figure out by hand that you can't memorize is how many centimeters or how many feet in a revolution. That's different in every problem. Every other conversion you can put on your reference sheet, and they're always the same. Feet to miles, inches to feet, minutes to seconds, days to hours. All those conversions never change.
Why is it that when when you're doing the equation on your calculator, you do like 1060 times 10 pi divided by 2 pi, it gives you 8.224. That's what I'm getting, because if you
All right, we'll just try it again. So we've got 168
times 10 pi,
times 10 pi. Okay, so I get,
divide that by 2 pi.
and I think that's what I had earlier, 0.523. And now divide that by 2 pi. Oh, that's going to come out the same.
8.224.
Divided by, oh, you know, let's see what happened. Let me see if we needed parentheses. I'm just going to type in 0.523 again. I'm going to put the 2 pi in parentheses. So yeah, that makes a difference. You have to put it in parentheses if you do it like that. The reason that it did that is because what it did is it took 0.523, it divided it by 2, and then it multiplied by pi. You know what I mean? And that's not what we wanted, but the way we typed it in, if you type the 2 pi in next to it, it's going to do that. If you want it to do this on your calculator, either type it in the way I did, one step at a time, or put it in parentheses. Did that fix it?
Sorry.
That should fix it. Okay, but that's a good point. That's something you might think you've done everything right, and then if it's a multiple choice question, you're not seeing your answer listed, and it's because of the way you typed it in on the calculator.
Yeah, I changed it.
Okay.
0.3.
Yeah. So be careful with that. If you're going to divide by something that's got multiple things in it, just put it in parentheses. Okay, anything else? All right, so the homework tonight, okay, just five questions. Okay, on page 100, 97, 98, 100, 108, and 110. Okay, we'll take a look at those 5 questions first thing tomorrow before our test. Okay, I'll also be after school today if anybody needs to stop by and review. Okay, remember for the test, mostly multiple choice. You can make a reference sheet and use it, and you can also use a calculator on it.